Hello everyone, good morning. My name is B. Pavan and my roll number is 209558041 and I belongs to Electronics and Communication Engineering and my AAT concept video topic for radar system and processing is block diagram and operation of pulsed radar. Pulsed radar system block diagram. A very pulsed radar system block diagram set was shown in figure below. A more detailed block diagram will now be given and it will then be possible to compare some of the circuits used with those treated in other contexts and to discuss in detail those circuits peculiar to radar. The block diagram of figure shows the arrangement of a typical high power pulsed radar system block diagram. The trigger source provides pulses for the modulator. The modulator provides rectangular voltage pulses used as a supply voltage for the output tube, switching it on and off as required. Block diagram of an elementary pulsed radar: transmitter, duplexer, antenna, receiver. This tube may be a magnetron oscillator or an amplifier such as the klystron traveling. If an amplifier, traveling wave tube or crossfield amplifier depending on specific requirements. If an amplifier is used, a source of microwaves is also required. While an amplifier may be modulated at a special grade, the magnetron cannot. If the radar is a low powered one, it may use impact or gun oscillators or trap at amplifiers. Below C band power transistor amplifiers or oscillators may also be used. Finally, the power portion of radar is terminated with the duplexer, which passes the output pulses to the antenna for transmission. The receiver is connected to the antenna at suitable times in the pulsar radar system block diagram. That is, when no transmission is instantaneously taking place. As previously explained, this is also done by the duplexer. As shown here, a semiconductor diode mixer is the most likely first stage in the receiver since it has a fairly low noise figure, but of course it shows a conversion loss. An RF amplifier can also be used and this would most likely to be a transistor or IC or perhaps a tunnel diode or paramp. Pulsed radar block diagram: trigger source, modulator, output tube, ATR switch, TR switch, antenna, video amplifier, indicator, detector, IF amplifier, mixer, local oscillator, angle data from antenna. If a diode mixer is the first stage, the first IF amplifier must be designed as a low noise stage to ensure that the overall noise figure of the receiver does not deteriorate. A noisy IF amplifier would play havoc with the overall receiver performance, especially when it is noted that the gain of a diode mixer is in fact a conversion loss, typically 4 to 7 dB. A cascade connection is quite common for the transistor amplifier used in the IF stage because it removes quite common for the transmission transistor amplifier used in the IF stage because it removes the need for neutralization to avoid the Miller effect. A better noise figure is thus obtained and thus the RF amplifier may have the further advantage of saturating for large signals, thus acting as a limiter that prevents mixer diode burnout from strong echoes produced by nearly targets. The main receiver gain is provided at an intermediate frequency, that is typically 30 or 60 MHz. However, it may take two or more down conversions to reach that IF from the initial microwave RF to ensure adequate image frequency suppression. A better noise figure is thus obtained, and the RF signal amplifier may have further advantage advantage of saturating for large signals, thus acting as a limiter that prevents mixer diode burnout from strong echoes produced by nearly targets. Another source of noise in the receiver may be the local oscillator, especially for microwave radar receivers. One of the methods of reducing such noise is to use a varactor or step recovery diode multiplier. Another method involves the connection of a narrowband filter between the local oscillator and the mixer to reduce the noise bandwidth of the mixer. However, in receivers employing automatic frequency correction, this may be unsatisfactory. The solution of the oscillator noise problem may then lie in using a balanced mixer on or a cavity stabilized oscillator. If used, AFC may simply consist of a phase discriminator which takes part of the output from the IF amplifier and produces a DC correcting voltage. If the intermediate frequency drifts, the voltage may then be applied directly to a varactor in a diode oscillator cavity. The IF amplifier The IF amplifier is broadband to permit the use of fairly narrow pulses. This means that cascaded rather than single stage amplifiers are used. These can be synchronous, that is, all tuned to the same frequency and having identical bandpass characteristics. If a really large bandwidth is required, the individual IF amplifiers may be stagger tuned. The overall response is achieved by overlapping the responses of the individual amplifiers, which are tuned to nearby frequencies on either side of the center frequency. The detector is often a Schottky barrier diode whose output is amplified by a video amplifier having the same bandwidth as the IF amplifier. Its output is then fed to a display unit directly or via computer processing and enhancing. Modulators. If in a pulsed radar system log diagram transmitter, the modulator is a circuit or group of circuits whose function is to switch the output tube on and off as required. There are two main types in common use: line pulsing modulator and active switch modulators. The latter are also known as driven power amplifier modulators and were called hard tube modulators until the advent of semiconductor devices capable of handling some modulator duties. The line pulsing modulator corresponds broadly to the high level modulator. Here, the anode of the output tube or its collector, depending on the tube used, is modulated directly by a stem system that generates and provides large pulses of supply voltage. This is achieved by slowly charging and then rapidly discharging a transmission line. The charging is made slow to reduce the current requirements and is generally done through an inductance.